Hello class, welcome to day one of remote learning. Day one, we're going to review some implicit differentiation. I'm going to use my stylus on the board. When I do put it on the board, it will click. I'll try to do it softly, but this is the best way for me to do this. We'll have to deal with it. So day one, I'm going to put my key here, and we're going to talk about reviewing derivatives. dy over dx, or y prime, or f prime of x, these are all derivatives. They are the change in y to change in x, or better yet, the change in the function with respect to the variable x. Let's talk about a review. First, I would rewrite this function as 5x cubed minus x to the negative 2 plus 6x to the 5 thirds plus x to the negative 1 third minus 3. That is rewriting the derivative. And now I'm going to take its derivative, because I cannot take the derivative in that first form with the root signs and this and that. I have to rewrite everything as a power function. I'm going to change my color. And its derivative is 15x squared plus 2x to the negative 3 plus 10x to the 2 thirds minus 3 over 2 x to the negative 5 over 2. That is its final derivative. You could rewrite it if you want. I have my handwritten notes posted on the portal. I blank notes. I have my handwritten notes. You could follow along on either one of those. But I'm going through what I'm doing here with the audio on how I did everything. Okay. I'm going to move my screen up. And we're going to talk about how do we take derivatives of other variables. So my first example, if you notice that these are the same variable, so it doesn't really matter. Second, taking the d dx, this is the d dy. My variable is y, so it's just going to be 12y squared, and technically it's dy because that's a variable on top over dy because that's a variable I'm taking with respect to. But this whole part is equal to 1, so it kind of goes away and we just get 12y squared. Same thing on the second example. It's just going to be 10r dr over dr. And the third one is going to be negative 6 u to the negative 4 du over du. But these are equal to 1. So I just get 10r, and I get negative 6u to the negative 4. That is when I take derivatives of an expression that is the same variable with I'm taking its with respect to. I'm going to move this on up. Well, how about when we take a derivative of an expression that variable is different than what I want to do? If you notice, this variable on top and this variable on bottom are different variables. So when I take this derivative, it's going to be 12y squared times extra dy over dx. This one's going to be 10r times the dr on top, because that's the variable of the expression, over dx, because that's the variable I'm taking with respect to. 24t cubed times dt over dx. And finally, it will be negative 6u to the negative 4 times du over dx. And we've talked about this before in the prior unit. If you want to do things with primes instead and make this 12y squared times y prime, or 10r times r prime, or 24t cubed times t prime, or negative 6u to the negative 4 times u prime. That is implicit differentiation, and we're going to be using that today to do more difficult examples. And I'm going to turn the page. I'm going to pause the video. Okay, we are going to take derivatives of implicit functions. X squared plus y squared is equal to 4 is an implicit equation because it has x and y together. It doesn't say y equals, so I'm going to take the dx of this whole function, and I'm going to get 2x times dx over dx, technically, plus 2y times dy over dx is equal, and the derivative of 0 and the derivative of any number, constant, is just 0. Now, talked about this, that is just equal to 1. And we were solving for dy over dx. I want to get the dy, I want to isolate the dy over dx. I'm going to do that by subtracting this over. I get 2y times dy over dx is equal to negative 2x. And I'm going to divide out by 2y. And I could clean it up a little bit. And I get dy over dx is equal to negative x over y. We've done this problem before. It's not any different. But that is my derivative. My change in y over change in x for this example is negative x over y. Okay, I'm going to move to my next example. It's going to be a little bit more work, but it's the same idea. I am taking, change to red, I'm taking the dx, or the change of the function with respect to x. I'm not going to write dx over dx any longer. It's kind of silly to write that out every single time. So when I take this derivative, I get 2x plus 12y squared times dy over dx. I'm not going to use primes anymore. I'm actually going to write it out the way it should. 6x squared plus 5 dy over dx. That is the implicit differentiation of the original function. I want to isolate the dy over dx, so what do I want to do? I'm going to get everything with the dy over dx on the left side of the problem. This is going to move, this is going to stay, this is going to stay, this is going to move. And when I do all that, I'm also going to factor out a dy over dx. So when I do all that, I get 12y squared dy over dx minus 5 dy over dx is equal to 6x squared minus 2x. And when I factor out the dy over dx, change to blue, I get dy over dx is equal to 12y squared minus 5 is equal to 6x squared minus 2x. And then get the dy over dx by itself. I just divide it by it all, and I get dy over dx is equal to 6x squared minus 2x all over 12y squared minus 5. That is my implicit differentiation to find the dy over dx. Nothing simplifies here. We have multiple terms, nothing in common. I'm just going to leave it like that. Last example on this page. Again, I want to take my dy, my ddx of this, define as derivative. And this is going to be a little bit more difficult, because if you notice in this problem, I have a couple of product rules. One here and one here. I'm going to do that work on the side. I got 3x squared turns into 6x, and y squared turns into 2y dy over dx. The second one I have is 4x. That turns into 4, and y turns into 1 dy over dx. So when I take this derivative, I'm going to change it to blue, I get, move this over here, I get 6y squared dy over dx. And then plus, I got to do my product rule, I got to do my crisscross. One crisscross is 6xy squared. The other crisscross is going to be plus 6x squared y dy over dx is equal to, again I got to do the product rule, one crisscross is 4y, the other crisscross is plus 4x dy over dx. That is the original first step in doing the implicit differentiation. I'm just going to make sure I have everything right. A little bit sloppy here. And again, I have all my notes online. You can look at them. I'm going to change my color here. I'm going to go to purple. This is going to stay. This is going to move. This is going to stay. This is going to stay. This is going to move. I'm also going to factor out. I'm just going to rewrite it. 6y squared dy over dx plus 6x squared y dy over dx minus 4x dy over dx is equal to 4y minus 6xy squared. I have all the y term, dy over dx terms on the left and everything that does not on the right. Change my color to green. Factor out a dy over dx. I get 6y squared. Thank you, Tania. 6x squared y minus 4x is equal to 4y minus 6xy squared. And when I divide it out, I get dy over dx is equal to 4y minus 6xy squared over 6y squared plus 6x squared y minus 4x. This one I could simplify if I wanted to because all my terms here are even, and I could reduce everything by dividing it by 2. I'm not going to in this case. I'm just going to leave it as is, and it's fine. You don't have to simplify or anything. Again, all my notes are on the portal if you want to just look at my handwritten notes. I'm going to turn the page, so I'm going to pause the video. Okay, our last page of notes is writing equations for tangent and normal lines. We're basing it off of this equation. I need an x value, I need a y value, I need a slope. And we talked about how slope can be found by taking the derivative. That was using when you just had an x value. Sometimes we have an x and a y value, and we have an implicit function. So f prime of x is really the dy over dx at some given x and y value. You'll have to be told what those are. And a normal line is just perpendicular to the tangent line, and you know how to make opposite reciprocals. None of this is new. Let's go through an example. I have to first take the derivative of this function. I'm going to get 2x plus 2y dy over dx is equal, and the derivative of 25 is 0. And I'm going to change my color, and I'm going to plug in -3 comma -4, excuse me. -3 +4 into this function. I get -6 plus 8 dy over dx is equal to 0. 8 dy over dx is equal to 6. Or I get dy over dx is equal to 3/4. And change it to purple. This is my slope of my tangent line. So when I write my tangent line equation, y equals slope 3/4 x plus 3 plus 4 using those x's and y's, and my normal y equals -4/3 x plus 3 plus 4. And that is the equation of my tangent of normal line using implicit differentiation. And now we're going to go through the last example, which will probably be the most work, because we are going to take the derivative of this to begin with. My d dx. But I got to be careful here because there is a product rule. I'm going to do it off here to the side. This is not 4xy squared. This is -4x times y squared. So that derivative is -4, and this derivative is 2y dy over dx. And when I take its derivative, I get, let me change the color, I get 6x minus, my first crisscross is -4y squared, my other crisscross is -8xy dy over dx plus 15y squared dy over dx is equal to, derivative of 15 is just 0. I'm going to plug in the numbers -2, -1 in for the x's and y's, and when I do that, I get -12 minus 4 minus 16 dy over dx plus 15 dy over dx is equal to 0. And if you notice, these two go together and these two go together, and I get -16. -16 minus dy over dx is equal to 0. Or I finally get, let's see, -dy over dx is equal to 16. Or finally I get dy over dx is equal to -16, and that is the slope of the tangent line. So when I'm done, I get my tangent line equation to be y equals -16, x plus 2 minus 1, and my normal line, y equals +1 over 16, x plus 2 minus 1. And those are my two equations. Again, all my notes are on the portal, and you can follow along and come to class if you have any questions.